Okay, so we left off in our packet on page 16. So I'm on page 16 in my module 1 packet. We're still in 1-2. I'm gonna go ahead and share screens with you. Remember, when you log into Clever, like you were just in for Alex, the other option is to go into Reveal Math. This takes us to our dashboard, and you can see what is slated for the calendar today. So it's the same as yesterday. When we view it, we can view the slideshow. And because we have done some of this already, we will have to slide through there a tab. So we explored, we learned, we did example 1, we did example 2, and we were just finishing up example 3. So we did example 3, and then there's an extra example 3. So that's where we're going to start today. So remember, the extra examples are not in your packet. We have to write these down. So just to the right of your check, I'm going to write down the problem since it's not there. And if I want to refer back to this, either on the quiz or when I'm trying to do the practice work, it helps for me to know what the original problem is, right? And not just to write down the answer. So coefficients, we have to multiply our coefficients first. Mrs. Jers was telling me that she talks about it like a mullet. The business in the front is the coefficient, and then the kind of tricky, crazy party part in the back is the variable. So when we multiply our coefficients, first of all, what are our coefficients? Are they good? -2 and -8. So what is -2 times -8? 16, and it's positive because 2 negatives multiply make a positive. And then I have m and m to the 5th. And our product of powers rule tells us we can do what with these two? We can add them. So this ends up being 16m to what power? The 6th. Excellent. So before we move on to quotient of powers, I would like you to jump to page 23 and finish up these two on the back. So just two, numbers 3 and 4 today. Numbers 3 and 4. These definitely get quite a bit trickier, right? So I'm going to give you just a couple minutes to do those before we go over them real quickly. All right, hopefully you've had a chance to attempt or think about these problems. Now, I always want you to start with the business in the front, right? The coefficients. So what is 3 times 8? 24, right? Now, we have to look at our similar bases. We have two different bases with exponents, right? We have m and n. So m, we have a 3 plus what? What is it if it's just m? There's just one of those, so we're adding one more to that. And n, what exponents do we have here? 2 and 3 is my second one. So if you're not sure what to do, be sure that you're showing these steps so that when you go back, you'll be like, where did Mrs. Love get the 24 from? Well, that was the 3 times 8, right? How did Mrs. Love get m to the 4th power? Well, she added 3 plus this 1 here. How did Mrs. Love get m to the 5th power? she added those exponents, right? If they have the same base, we can add the exponents. That one was a little bit tricky one to start on, wasn't it? Because it had multiple variables, multiple bases. So the next one, what's our coefficients? 9 and -8. What's 9 times -8? Go ahead, no. -72. And then I have p to the 4th and p to the 2nd. So what is 4 plus 2? 6. Do you see how we got p to the 6th power? All right, so now we're gonna go back and look at our coefficient of powers. So they want way back here, this explore should have been, there we go. Not sure why this explore was here. So we have to think about our inquiry. How can we simplify a quotient of powers with like bases? Do you remember from yesterday what quotient means? The answer to what kind of problem? Not multiplication, but division. The answer to division problem. So let's look here. So the point X can be dragged to the right and the left. So let's show set 1. So when I drag this, what is happening? They're still getting bigger. Now what is it equal to? It's equal to X. So how did they get X from X cubed divided by X squared? Or X to the 4th divided by X to the 3rd? Well, what exponent would be on X if we showed it? William? 0. Not 0. It would be 1. There would be a 1 up here. So you could pretend that this is a 1. So how did they get 1 from 3 and 2, or 4 and 3, or 5 and 4? How did they get 1? Any guesses? What do you think, Will? They are dividing, but how did they get the right exponent? So 3 divided by 2 is not 1, right? What do I do with the 4 and the 3 to make 1, or the 5 and the 4 to make 1? If the product of powers was to add, the quotient of powers, what's the opposite of addition? No. Subtraction. So they took 3 minus 2. Does that make 1? Yeah. 4 minus 3. Does that make 1? Same for 5 and 4. 5 minus 4 is 1. All right. So let's see these other sets. So here is set 2. Now when I move these, what do these equal to? X to the 2nd power, X squared. So are they still subtracting? Does it hold true? Yes, if we subtract the exponents. Now, are they taking the bottom exponent minus the top exponent? Or does the order matter with subtraction? What do I do here? What are they doing? Bottom minus top, top minus bottom, order doesn't matter. What do you think? Top minus bottom. Okay, so 9 minus 7, 8 minus 6, and 7 minus 5, those all equal 2. So let's go back here. All right. So now, so how do we simplify a quotient of powers with like bases? We take our top exponent minus our bottom exponent. And again, it has to be like bases. The bases have to be the same. All right, so we have to make sure that it works for set 3. Does it work still? The top minus the bottom, the top minus the bottom, the top minus the bottom, the top. So it works. So that is what we are going to look at today, is the quotient of powers rule. So how can you simplify a quotient of powers with like bases? Remember, we're going to subtract the bottom from the top, or the bottom, I'm sorry, the top minus the bottom. All right, so we are gonna skip ahead to some examples. That was extra. All right, the quotient of powers. This begins on page, where do we leave off? 17. So remember, if you're ever struggling with these, you can go back and do that explore on your own. Remember, this is going to walk you through the first part of these notes on page 17. Make sure it's pointing out.
You can simplify the quotient of powers with the same base. Write 3 to the 6th power as a product of factors. Write 3 squared as a product of factors. Divide out common factors and simplify. 4 factors of 3 remain in the numerator, so the quotient is 3 to the 4th power. Notice that the difference of the exponents in the original powers is the exponent in the final quotient. You can divide powers with the same base by subtracting the exponents. The quotient is x to the 4th power.
Okay. So this is going to take us to our words. It says right there in your packet, you can simplify a quotient of powers with like bases using the quotient of powers property. The group of integer exponent properties is called the law of exponents. So here it is in words. It's already written there for you. It says to divide powers with the same base, subtract their exponents. Do you guys see where we are in the bottom of page 17? Algebra, they're showing it with letters now. As long as a does not equal 0, this works. You can subtract the exponents. And finally, showing you with numbers, 3 to the 7th divided by 3 to the 3rd is 3 to the 7th minus 3, or they would like you to write in there 3 to what power? What's 7 minus 3? It is 4. So right here on the bottom of page 17, we're writing 3 to the 4th. Okay? That was the only thing you guys had to write there. So when we talk about it in that right column, when simplifying a quotient of powers using the quotient of powers property, why do the bases have to be the same and not like x to the 8th or y to the 3rd? So if I wrote out x to the 8th and y to the 3rd, so if I wrote out x times x, boys times x times x times x times x times x times x, is that 8? Divided by y times y times y. Can I cancel anything out? No, so this cannot even be simplified. So this does not have common factors. Remember, our base is the factor. So we can't cancel anything out if we don't have common factors, right? All right. Let's look at example 4. This begins on page 18 in your packet. So simplify x to the 8th divided by x squared. How do you think it'll help us simplify? We know we can do what if we have like bases? Subtract. So let's do it. All right, so we're going to move through the steps to be sure we're understanding. First, they wrote the expression. Easy enough. Next, they used the quotient of powers property to write out x to the 8th minus 2, right? So focus, please. And then, finally, we have to do that part, right? X to the 6th. So that's what we're putting in that very, very light box. 8 minus 2 is 6, so we're writing x to the 6th power. And then finally it says, so x to the 8th divided by x squared equals x to the 6th power. Not too bad, hopefully. So here is our check. Another method you could use to simplify would be to write it out, right? We could have written out 1, 2, 3, 4, 5, 6, 7, 8 divided by 1, 2, and it cancels out, and then we add them up. There's 1, 2, 3, 4, 5, 6 left. That's another method. So describe another method. I'm just going to draw my little arrow over here. There it is. All right, here is your check. We are simplifying x to the 12, I'm sorry, z to the 12th divided by z to the 4th. Our quotient of powers rule says we can do what? We can simply subtract the top exponent minus the bottom exponent. That's what your quotient of power rule says. So what does it equal? Z to what? The 8. I like to put a line through my Z, otherwise sometimes it starts to look like my 2. Because I don't do crazy curly 2s like some of you. Alright. I believe there may be an extra example, let's hope. Yay! Alright, so just below that, we are going to simplify x to the 10th divided by x to the 3rd. What do we get then? This is really x to the 10 minus 3. So it equals x to what power? Make sure you're checking this understanding with us. So when it gets time to practice, that you know how to do it. What do you get, Noah? Excellent. 10 minus 3 is 7. All right, here is example 5. Hawaii's total shoreline is about 2 to the 10th miles long, and New Hampshire shoreline is about 2/7 miles long. Well, if we were trying to figure out how much more, then we would subtract, but this question is asking about how many times longer, how many times longer. That's telling us we have to divide instead of just subtract. Is Hawaii's shoreline than New Hampshire's? So we're taking the bigger one divided by the smaller one to see how many times. Okay, so we're going to perform division and we're going to use our quotient of powers rule. So it's going to take us step by step through here. Well, 2 steps. So they wrote out the problem. 2/10 divided by 2. I'm sorry, 2 to the 10th, not 2/10. 2 to the 10th power divided by 2 to the 7th power is equal to 2 to the 10th to the minus 7. So then we need to fill in that part. What is 10 minus 7? 3. So we need to be writing under example 5 here, 2 to the 3rd power. And then we simply need to simplify. What's 2 cubed? That's one we should remember. It is 8. So Hawaii's shoreline is about 8. It's about 8 times longer. Now this one is telling us that Alaska's shoreline is about 3 to the 8th power miles long. Explain why you cannot use the quotient of powers property to simplify the expression 3 to the 8th divided by 2 to the 7th. Why can't we do that? Good, they're different factors. They don't have the same base, so they are different factors. Excellent. We'd actually have to do that like we were doing before. Here's your check. Yes. Alaska's shoreline is 0. Why would it be 0? You can do it, you just can't do it using quotient of powers rule. I would have to figure it out, right? I have to put in 3 to the 8th power and then divide 2 to the 7th power. Okay? So here's your check. It is on page 19. We're almost there. All right. So the table shows the seating capacity of 2 different facilities. About how many times as great is the capacity of Madison Square Garden in New York City than a typical theater? So we're saying 3 to the 9th divided by 3 to what? The 5th. This equals 3 to, remember we take the top exponent minus the bottom exponent. So that equals 3 to what power? The 4. So, man, they were so mean to us. Does that equal 64 or 81? 81. If we wrote that out, we would say 3 times 3 times 3 times 3. Then we would think 9 times 9, and we know that is 81. All right, so don't get tricked by their bad math, right? All right, dividing powers. Here's an extra example. Let me actually be able to show you. It wants to know how many times more people speak French than Sicilians? Sicilian? So 2 to the 6 divided by what? 2 to the 2 or 2 squared? Or 2 to the 2nd power. So I'm going to use this little space here and say 2 to the 6 divided by 2 to the 2nd equals 2 to the 6 minus 2. So 2 to what power is that? 2 to the 4th, which is 16. Equals 2. Okay. Questions about those 2 checks? Do you see where we're getting them? Now, sometimes we're going to have multiple bases that we divide. So do you see how we have multiple bases now? With our power, product of powers, we had multiple bases too. And we're going to think about that very similarly. So we can group the factors, right? We can group the 2s, we can group the 3s, we can group the 5s. So let's look. They wrote the expression, they did that for you. They set it equal to how we would group it. They grouped that for you. And then using the quotient of powers rule, they wrote this out for you, right? They took the top exponent minus the bottom exponent and kept the base the same. So this first one is 2 to what power? What is 5 minus 2? 3. The next one, make sure you're writing it in your packet. Sorry, it's hard to see. Let me make that bigger. The next one is 3 to what power? What's 5 minus 4? 1. Do I write 1 typically? No, I can just write what? Just the 3 is fine by itself. And 5 is to what power? 2 minus 1 is 1, so I'm just leaving that alone as well. Now, does this problem look a whole lot simpler than the first one? For sure, we're definitely getting much more simplified. So there it is, they wrote out the ones, that's totally okay. Then we actually have to do it. So what's 2 cubed? 8. 8 times 3 times 5. If you want, you can write that one there to show that extra step. And what is 8 times 3? This is 24 times 5, so half of 24 is 12 times 10. So therefore, they did 8 times 3 times 5. 24 times 5 is 120. So, in other words, 2 to the 5th times 3 to the 5th times 5 squared divided by 2 squared times 3 to the 4th times 5 is equal to 120, right, Dace? Focus, please. All right. So why is it important to group terms by their common bases? Why is that stuff important? That way we know what exponents we can subtract, right? We can't simplify it, yeah. And it's easier to see for sure. All right, ooh, this should be our check. So on page 20 is our check for this example. Making sure you understand it. Take some time and do this right now. 2 squared times 3 to the 3rd, or 3 cubed times 4 to the 5th, all over 2 times 3 times 4 to the 4th. So be sure you are completing this check right now. I'm going to give you just a minute to do so. If you notice the selection of our answers, we don't even have to multiply through, right? They simply want us to simplify in exponent form. So if I'm looking at my 2's, I have 2 to the 2 minus 1. If I'm looking at my 3's, I have 3 to the 3 minus 1. And if I'm looking at my 4's, I have 4 to the 5 minus 4. All right, so this is really just 2, right? 2 to the 1st power times 3 squared times 4 to the 1st power, or 2 times 3 squared times 4. So what did you get for your answer? Hopefully you got letter A. If you didn't, make sure you fix it and show why. I'm hoping there's an extra check here. Yes. So you're going to have to write this one out, right? Because it's not in your packet. And that's little. 5 to the 6th power times 7 to the 4th times 8 to the 3rd. And that is all over 5 to the 4th times 7 to the 2nd times 8 to the 2nd. So make sure you are checking that. So you're saying 6 minus 4 is 5 squared. So that narrows it down to B and B. And 4 minus 2 is to the 2nd power. So now it has to be B. We're just going to make sure 3 minus 2 is 1. So it's got to be B. So again, 5 to the 6 minus 4 times 7 to the 4 minus 2 times 8 to the 3 minus 2. So 5 squared times 7 squared times 8 would be our answer simplified. All right, I would like you to turn to page 23. We should have another couple problems that we can simplify. And that would be numbers 5 and 6. So 5 and 6 should definitely be done today. I'm going to go ahead and stop sharing my screen so this is nice and big. 5 and 6. We have just enough time to do numbers 5 and 6. So take just a second. We'll go over that in about a minute. All right. So what did you get for number 5? B to what power? B to the 7th power. Remember, we are subtracting. Be careful. And here you have 5 to what power? 2. And 6 to what power? Also 2, right? And 8 to what power? It's good. So do you see how we can simplify those readily? Guys, don't be putting your stuff away. We still have 2 whole minutes. You can chill out. Chill out, chill out, chill out. Okay, questions, concerns about quotient of powers rulings? Nope.